Good morning, students. And how are we doing this morning? Very well. So to begin today's lesson, I will be sharing my screen with a short video. I would like you to pay keen attention to. Attention to the video.
Many of you know the Pythagorean theorem, possibly not by name, but the equation a squared plus b squared equals c squared is something that has been drilled into students' minds. However, some may not know the history behind this theorem. For centuries, people all over the world have used the Pythagorean theorem in construction, land surveying, and other activities. This theorem is also involved in a cult, oxen sacrifice, and a man's death, which is pretty crazy for a small equation. I am Mr. Durstein, and this is a brief history of the Pythagorean theorem. Although the Greek mathematician Pythagoras is given credit for this theorem, it was in use for over 1,000 years before he was born. Ancient Babylonian master builders used the Pythagorean theorem in construction, and we know that they are aware of the relationship between the sides of right triangles because of an inscribed tablet with Pythagorean triples. A Pythagorean triple is a set of 3 whole numbers in which you can square the first 2, add them together, and get the square of the last, such as 3, 4, and 5. The Chinese were also aware of the relationship between the sides of the right triangle involved in the theorem. It is believed that they possibly may have even proved the theorem before Pythagoras using a method involving the areas of squares. And Egyptians used the theorem as an aid to construct right angles in many of their structures. Ancient Egyptian architects wanted perfect 90-degree angles on the walls of their buildings to improve stability, and the relationship involved in the theorem helped achieve this. Now, even though these ancient civilizations were aware of the relationship involved in right triangles, they did not write it down, or they lost it on their desk. Who knows? The credit of writing it down and proving it goes to Pythagoras, and his reward was getting everyone's favorite theorem named after him. Pythagoras was born around 500 BC on the island of Samos in Greece. Not much is known of his youth, but it is thought that he did a lot of traveling through Egypt and surrounding countries to study. He finally settled in the Italian city of Crotone and began his brotherhood, or cult, whichever you feel comfortable calling it. This group became known as the Pythagoreans. Now, the Pythagoreans loved math, and I really stressed loved. They pretty much worshipped mathematics and had rituals and prayers within their meetings. They believed that numbers ruled the universe and that numbers were endowed with mystical and spiritual qualities. Now, it was the Pythagoreans, whether it was Pythagoras by himself or someone else in the group, that came up with a proof involving the relationship between the sides of a right triangle. And legend has it, when Pythagoras completed his theorem, he sacrificed 100 oxen. Now, please don't get that excited when you prove this theorem. Clapping and cheering is cool. But sacrificing animals to the number deities crosses the line. Oh, I almost forgot that I mentioned this theorem was involved in a man's death. One problem the Pythagoreans noticed with their new theorem was that when a triangle had the legs with the size of 1, they could not measure the hypotenuse with a ruler divided into fractional parts. We know these numbers as irrational numbers, or numbers who cannot be written as a fraction and whose decimal goes on forever without repeating. The Pythagoreans called these unutterable numbers. For a group that worshiped numbers, finding a number that could not be expressed, no matter how hard they tried, really freaked them out. One of their members mentioned the existence of these unutterable numbers to the public, and what the Pythagoreans did to him is unutterable in a classroom. Well, that pretty much sums it up. I hope you enjoyed this brief history of the Pythagorean theorem, and to learn how to calculate and apply the theorem, please stay tuned and listen to my lecture.
Okay then. So for today's lesson, we will be looking at Pythagoras Theorem, right? And the objective of today's lesson is for you students to be able to get at least 3 of the missing sides of different right angle triangles using the Pythagoras Theorem. Here's a diagram of a triangle. Can everyone see this diagram? Very well. So looking at this triangle, we see we have, what type of triangle is this? Yes, Leo? Yes, it's a right angle triangle, and we know it's a right angle triangle because, yes, right? Because of the little square we see here, sitting here like it's formed a chair, right? So once we see this little sign, we know that the triangle, it's a right angle triangle. We see we have the word hypotenuse, leg, and a leg. So the hypotenuse of the triangle, it's the longest side of the triangle, right? So it's the longest side. And the side opposite to the hypotenuse, it's called the opposite side. And then we can just leave this as another leg. We call it any legs that we can choose, right? So now we see that this is length A, and length A of angle A. Do you see that? So leg A of angle A. The hypotenuse. What is going to be that angle? Yes, Shania? Yes, this little square here, this is going to be the angle. And then leg B, or the opposite side, what is going to be that angle? Yes, B. Do you see that? Very well. What we're going to do now, I'm going to draw some triangles on the board, and I would like you to identify the hypotenuse and the 2 different legs, right? Hypotenuse. Yes, Hannah? Okay, let me put some labeling. B, C, D. The hypotenuse, Anna. Yes, B, C. So, what and what is going to be the 2 legs, Danielle? BD and CD. Very good. So this is leg and this is a leg. Very good. Where is going to be the hypotenuse since you don't see that little square? A, B, C. Yes, Aki. AB, right? So AB is going to be the hypotenuse. So even if you don't see this little square, remember I told you that hypotenuse is the longest side on the triangle, right? So the other 2 sides are going to be the leg, right? Good. So this is leg and this is leg. Do you understand that? Very well. So we can move on. Okay, students. So what we're going to do now, I'm going to play another video where we'll go a little bit more in depth about Pythagoras Theorem and okay, so pay attention.
Hey guys, in this video we are going to be using Pythagorean theorem to solve for a missing side of a right triangle. So that side could be the hypotenuse or that side could be a leg. So recall that the Pythagorean theorem formula is a squared plus b squared equals c squared. where A and B are the legs, and the two legs, A and B, are the sides of the right triangle that form the right angle. So A and B intersect at 90 degrees. And then C is the hypotenuse, and that's the longest side of the right triangle, and it's also going to be the side that is directly across from the right angle. So we're going to look at the steps. For the steps for this process are to write the formula, a squared plus b squared equals c squared, substitute the numbers or the values into the formula with the correct variables, so A and B are the legs and C is the hypotenuse. Solve for the missing side using inverse operations, and remember that the hypotenuse must be the longest side.
So based on our video that we just watched, we know that the longest side is the hypotenuse and the other two sides are legs, right? And when we add and square these two sides, we must get the square of this side. Okay? So C square, this is C. C square is equal to, we have to square A or AC. It's the same thing. Okay? So let's say, for instance, we want to find C. Looking at this formula, we see the square is onto the C. So what we're going to do, we're going to move the square over the equal sign. And then we have to square this entire thing. So simply what we do, we put the square root of a squared plus the square root of b squared. It's the same as this. Okay? And if we do make A the subject of the formula, it's going to be c squared plus b squared, the square root of it. And if you want to find b, it's going to be the square root of a squared plus the square root of c squared. Do you understand that? So these are the formulas you need to remember. And you also need to remember that Pythagoras Theorem states that the side of the hypotenuse, that the square side of the hypotenuse is equal to the square side of the other two sides. Okay? Okay, so take these formulas in your books and then let's work some examples. Example 1. Which side are they asking us to find? Yes, Alicia, C. And C is called the, yes, hypotenuse. So from the formulas that I gave you, which one of the formula would we use? C is equal to a square root plus the square root of b squared. Very good. What next are we going to do? We're going to put in what we know. So which side is A? We're going to give this side A and this side B. So C is going to equal to the square root of 5 squared plus the square root of 12 squared. Right? C is now going to equal to 5 5s, 25 plus the square root of 12 12, 144. Everyone seen that? Very good. So let's put these two together. Square root of 169, Tisha? 13. Very good. So C is going to equal to 13. Does everyone see that? Very good. Let's work another one. So we got example 2. Damiana, what formula did you use? B squared is equal to C squared minus A squared. Okay. Yes, Tim. You didn't use it. Okay. So remember, Pythagoras Theorem states that the longest side, which is the hypotenuse. When it's square, it's equal to the leg, the first leg, plus the square of the second leg. Right? So if we want to find for b, we'll move a square over the equal sign. It's going to be c squared minus a squared, and that's going to equal to b squared. Do you remember seeing this? Very good. So let's put in what we know. So b squared is going to equal to c is going to be 15 squared minus 9 squared. Do you see that? So 15 squared is going to equal to, yes, 225 minus 9 nines, 81. So when you take 81 from 225, what are you going to get? Yes, 144. But we still want to find for b, and the square is onto the b. So to find b, it's going to equal to the square root of 144. So therefore, b is going to equal to 12. Do you understand that one? Very good. So you can make your necessary correction. Let's work one more. Okay, Unil. How are we going to work this one? Which formula did you use? First thing, which side do we have to find? A. So which formula did you use? A squared is equal to c squared minus b squared. So Aki made A the subject of the formula. So c squared minus b squared is equal to a squared. Right? Good. So let's put in what we know. A squared. We know that c is 17 centimeters squared plus minus 15 centimeters squared. Is everyone seeing that? And what, when we squared 17, what are we going to get? 289 minus, when we squared 15, what are we going to get? 225 centimeters. Very good. So when we take 289 from 225, what are we going to get? 64. But remember, we still want to find for a, but the square is onto the a. So we move the square and we do the inverse, which is the square root. So the square root of 64, a is going to equal to 8 centimeters. So you can use the first formula that we did in the first one, or you can use the one that Demiana and O'Neill used. Okay? Very good. So what I'm going to do now, I will be sending the link for you to gain access to your worksheet. And you will have 20 minutes to complete your worksheet. So you may begin. So everyone is finished sending their worksheet to me, right? Through my email? Very good. I will send your homework through your emails. Good. So what I would like you to do is to construct any one of the triangles that you had on your worksheet. Anyone, construct it in your book, and then I would like you to turn on your camera and share it with the class. Okay, so take 6 minutes and you may begin. So we are all finished, right? Give yourself a round of applause. The class is now dismissed. You may exit.